So inverse time dilation, is that a thing? Well, apparently not. And ChatGPT actually says that there's no concept known as inverse time dilation. Time dilation apparently can only go in sort of one direction, as in an observer can see a moving clock going slower than itself. And it cannot, there's no inverse of it. And in addition, time dilation in terms of special relativity has to be reciprocal. Okay, so there's a few problems with that. And the first of all is that inverse time dilation actually exists and it's been proven experimentally in the Hafele-Keating experiment of 1971. Now, in this experiment, aircrafts carrying atomic clocks flew around the Earth, and we took those clocks to compare it with Earth's clocks. And let's look at the results. All right, first of all, for the eastward flights, less time had occurred on the aircraft's clocks. So in other words, from Earth's perspective, the airplanes experienced time dilation. But if we turn that around, from the airplane's perspective, the Earth's clocks experienced inverse time dilation, because in the aircraft's perspective, more time had ticked for Earth. So from the perspective of the airplane, Earth's clocks ticked faster. Not slower, faster. Again, an existence of inverse time dilation. Now, some people are not going to be so certain. They're like, oh, well, maybe there's some wonky time thing that happened, so we cannot say the Earth's clock ticked faster. First of all, Earth's clock ticked faster regarding to the airplane. There's no question about that. If less time transpired on the aircraft's clocks, when they compare clocks, then yes, at some point, Earth's clocks have to have ticked faster for it to be ahead of the airplane's clocks. But let's look at the second part, which is the westward flight. No, this is where things get even more interesting. See, for the westward flight, more time had transpired on the aircraft's clocks than Earth's clocks. In fact, for the airplane, they gained at approximately 270 nanoseconds when they landed on the westward flights. So from Earth's perspective, from our perspective basically, we saw that the airplane flying clocks gained time. In other words, we saw them experience inverse time dilation. So again, the inverse time dilation would be the inverse of time dilation, right? We see them gain fast. So from our perspective, the clocks in airplanes ticked faster. Not slower, faster. So again, this is inverse time dilation. So this is a very important concept that for some reason is not a concept. I could have related to, kind of like the number zero or invention of negative numbers. It's an important concept that should be acknowledged, but it's not. And again, this is one time in which case inverse time dilation absolutely occurs. Now, the other time this could occur will be in the twin paradox. So the next time this occurs would, of course, be the twin paradox. And again, I made an in-depth video explaining the twin paradox and how to resolve it. And so basically in this case, we know for a fact that the Earth's twin will see the moving twin's clocks is dilating. We know that for a fact because by the time the moving twin comes back, they'll be younger than the Earth's twin. So again, this is not up to debate. However, we also know from the moving twin's perspective, by the time they get to Earth, they're a lot younger than the stationary twin. And in this case, and again, the reason why this occurs in the video I've made explaining twin paradox is because of length interaction from the perspective of the moving observer. But however, it's important to note that from the perspective of the moving twin, the Earth's twin experienced inverse time dilation because, again, they didn't experience time dilation because obviously Earth's clock did not tick slower. It didn't tick slower. See, look, the moving twin comes back as a young person. The twin on Earth is an old person. How can you possibly tell me that the moving twin sees the Earth's twin's clock is dilating slower? That's not possible. Again, same as the Hafele-Keating experiment, right? If one clock is slower than the other clock, then objectively speaking, we know for an absolute fact that from the perspective of the slower clock, the faster clock ticked faster than. Right? That's not up to debate, right? That's not an opinion. That's not subjective. That's not theoretical. We know for a fact in experimental cases of situations in which case one clock ticked faster than the other, and in other words, from the perspective of the slower clock, the faster clock has to have experienced inverse time dilation. Now, again, in the case of the stationary twin, experiences inverse time dilation when viewed by the moving twin. So again, this is another example in which case inverse time dilation occurs. So some people are going to say that, wait, isn't time dilation reciprocal? As in, two moving, if one person moves away from the other, they will both see each other's clock as slowing down. Now, first of all, yes, Einstein did say that. Again, it's easy to assume that because obviously length interaction is reciprocal. We know that for a fact. But is time dilation reciprocal? Okay, well, So, according to ChatGPT here, reciprocal time dilation has not been proven experimentally. Now, keep in mind, sometimes we ask it will claim that it has been proven experimentally. Although ChatGPT does get confused. Sometimes it thinks regular time dilation versus reciprocal. However, the reciprocity of time dilation has not been proven experimentally. And one thing to remember is, obviously, we have things like CERN tests where we shoot particles. But the problem here is that obviously we can see the particle having time dilation, but we don't know what the particle is seeing to us, right? Are they seeing us experiencing time dilation, or are they seeing our time ticking speed up? But regardless, I'm not here to argue against the reciprocity of time dilation. Time dilation might be reciprocal, at least in certain circumstances, but certainly there are some times where time dilation is not reciprocal, and then we do definitely see inverse time dilation. We know that through the Hafele-Keating experiment. We know that for a fact. Again, the Hafele-Keating experiment has already proven that time dilation can be inverse. So, the exploration of inverse time dilation reveals its intriguing presence in various scenarios, revolutionizing our understanding of the fabric of the universe. This research contributes to the broader field of special relativity and invites future investigations to delve deeper into the mysteries of time and space dynamics. As we continue to unlock the secrets of inverse time dilation, we move one step closer to unraveling the profound intricacies of the cosmos. And thanks for watching.